So we start with triangles, and in class 9 we have a topic which is called congruent triangles, right? Congruent. So triangles, tri comes from the word three, right? Tri means three. And a triangle obviously has three sides, three angles and three vertices. A triangle has got three sides, right? If I take this triangle ABC, it has three sides, A, B, B, C, C, A. It has three angles, angle A, B, and C, right? And these are the three vertices, okay? A, B, C are the three vertices, three sides, and three angles. So what is congruency? Congruency refers to identical size and shape. So if you have two triangles which are exactly equal in terms of size and shape, okay, we are having two triangles which are exactly identical to each other, then we can say the triangles are similar or congruent. And the symbol for congruency is like this, right? We write congruency like this. So this means it is congruent. That means if I am going to cut out this triangle and paste it on this, then they will exactly superimpose the other. So exactly of the same size. It should not be one small and one big. They should be of the same size and same shape, right? Same shape, same size and same shape. So whenever we are having two triangles of the same size and shape, we can say the triangles are congruent. So this chapter is all about congruence of triangles. Of course, other figures can also be congruent. So this is the definition which we have to know, that it means in all respects whose shape and size are both same, right? So congruent means equal in all respects, or figures whose shapes and sizes are both same. For example, if I draw two circles of the same radius, if I cut out this circle and place it on this, they are going to superimpose. These are called congruent circles. Of course, this chapter is dealing with only triangles, so we need to elaborate on that aspect, right? So here, how do we prove the triangles congruent? That is the most important thing in this. How to prove the triangles congruent. So there are some conditions for that. So let's go to the conditions before we start the exercise. So here, first, conditions for two triangles to be congruent. Conditions for two triangles to be congruent. This is what we are going to discuss. Conditions for two triangles to be congruent. So let's take the first condition. The first condition is SSS. Now, what is the meaning of SSS? Is that when we have two triangles whose corresponding sides are equal, that means let's take this triangle ABC and DEF. Okay, let's take this triangle as 2, 3, and let's say we have the side 4. So we are having a triangle 2, 3, and 4. Right? So this is the triangle 2, 3, and 4. Now this triangle is also 2, 3, and 4. So what we observe is that the corresponding sides are equal. So AB is equal to DE, BC is equal to EF, and AC equal to DF. So whenever we have all the corresponding sides equal, then we can say the triangles are congruent. And which condition are we going to use for congruency here? SSS. So this is condition number 1. Second condition is SAS. SAS stands for two sides and one angle. Two sides and one angle. So if you are having two triangles, A, B, C, and DEF, if two sides, suppose AB is equal to DE and AC is equal to DF, suppose these two sides are equal, and the angle between them is equal, then the triangles are congruent by SAS. Okay, two sides are equal. Let's say this is 5 and 6, this is also 5, 6, and this angle is 50 degrees, this angle is also 50, then I can say these two triangles are congruent. And which condition are we using here? SAS. The third condition is ASA. Now, ASA stands for angle side angle. So we are having two triangles, let's say ABC and DF, in which angle A equal to angle D, AB equal to DE, and angle B equal to angle E. So what is happening? The side is between the two angles. So this is called ASA. This is SAS. Two sides and one angle in between. This is two angles and one side in between. ASA. Also, we must remember that if the side is not between the angles, then we can say the triangles are also congruent by AAS. So there is a difference between ASA and AAS. In this ASA, the side is between the angles. Here, the side is not between. So here we have angle ABC, and let's say this triangle DEF. Angle A and D are equal, B and E are equal, and BC and EF are equal. So unlike the third condition, the side is not between the angles, it is separate. So this is angle side. And the last condition is RHS. RHS stands for right angle, hypotenuse, side. RHS stands for right angle, hypotenuse, side. So this is applicable only for right angle triangles. So we need a right angle triangle. So let's say angle B is 90 and angle E is 90. So we have two right angles. The hypotenuse is equal, AC equal to DF, and any one side, either the perpendiculars or the base. So this is called RHS. Right angles are equal, B equal to E. The hypotenuse, that is the side opposite to the right angle. So AC equal to DF, and other side, any one side, either BC equal to EF and AB equal to DE. So any of these sides can be equal. Of course, what is compulsory is that it has to be 90 and the hypotenuse has to be equal. Then we say RHS. So these are the conditions for two triangles to be congruent. So when we have to prove triangles congruent, one of these conditions have to be used. So how do we use these conditions now to prove the triangles congruent is the next part of this chapter. So let's take the first question. AC equal to AD given. AB bisects angle A. That means these two angles are equal, 1 and 2. And remember to draw diagrams in all questions. Without diagram, kindly do not attempt any geometry questions. Diagram is important. Show that triangle ABC is congruent to triangle ABD. We have to take these two triangles. Which triangles are they talking about? Triangle ABC and triangle ABD. Now remember, in this, already two conditions are given to you. What is that? AC equal to AD, already given. Condition number 1, AC equal to AD, given. And this is bisector. Bisector means these two angles are equal. So angle 1 equal to angle 2 also given. Why is it given? Because it's given that AB bisects angle A. And now we have to see the third condition, and that is very evident from the figure. Look at this line AB. It is part of ABC as well as ABD. This belongs to both the triangles. So we say it is common. So AB is equal to AB common. So two conditions were already given. AC equal to AD. 1 equal to 2. Angle 1 and 2 are equal because AB bisects angle A, and AB is common. So AB is common because it is part of both the triangles. So we have what? Two sides and one angle in between. So triangles are congruent by SAS. Triangles are congruent by SAS. So I'm going to write here SAS. And now what can you say about BC and BD? Now remember, once the triangles are congruent, all the corresponding sides of the triangles are going to be equal, right? So BC will be equal to BD. We will say CPCT. You can note down what CPCT stands for. CPCT stands for corresponding parts of congruent triangles, right? CPCT stands for corresponding parts of congruent triangles. CPCT, corresponding parts of congruent triangles, CPCT. So we need not write the full thing. We can just write CPCT. So remember, after proving the triangles congruent, any angle or side is asked, what is the relation between those sides? Remember that the corresponding sides of the triangles will be always equal. corresponding angles will always be equal. So because that two congruent triangles mean they're exactly same in all dimensions. So all the sides and all the angles will be definitely equal. So what can we say about BC and BD? They're equal by CP, CT, right? So every question we need to find out three conditions and prove the triangles congruent. Now let's look at question number 2. This is a quadrilateral given. Here AD is equal to BC. Already this is marked, and angle DAB. This angle and this angle are equal. Two conditions again given. Prove that triangle ABD and triangle BAC are congruent. Okay. So what are the triangles we take? We are taking triangle ABD, triangle ABD. Okay, just observe this triangle ABD, and figure has to be drawn. ABD, this triangle here, and BAC, this triangle here, triangle BAC. So this is one triangle ABD, this is the second triangle BAC. Already two conditions are given. First condition, AD is equal to BC given. AD is equal to BC given. Angle A and B are also equal given. Angle A equal to angle B given. Now, just like we did question 1, you find that AB is common for both. Whether I'm taking this triangle, see, this triangle I'm taking ABD, or I'm taking this triangle ABC. What is happening? This AB is getting overlapped. AB is common, right? So which means that I can say that this is common. AB is part of both. AB is common. So again, I've got three conditions: side, angle, and this is common here. So we can say triangles are congruent by SAS. Triangles are congruent by SAS. And both these parts, I told you, once the triangles are congruent, all the corresponding sides and angles will be equal. So I can say BD equal to AC, CPCT. And I can also say that ABD equal to BAC, CPCT. So once you prove the triangles congruent, the other parts are very simple, because all you need to write is CPCT, corresponding parts of congruent triangles. Moving on to question number 3. So here AD and BC are equal perpendiculars. AD and BC are equal perpendicular. So this is 90-90. Again, we have two conditions. Show that CD bisects AB. To prove CD bisects AB, we have to prove that OA and OB are equal. Bisects means division into two equal parts. So we have to prove that this line is bisecting this. So we have to prove OA and OB are equal. So which triangles are there? Only two triangles are there. AOB and this triangle AOB and this triangle BOC. So we will take triangle AOD. Okay, this is our triangle here. And this triangle BOC. What are the conditions given? AD is equal to BC, already given. Angle A equal to angle B, 90, already given. They are given equal perpendiculars. Perpendiculars means 90. And the third condition is not given, but we know lines and angles we did this there. These are called vertically opposite angles. So angle 1 is equal to 2 because they are vertically opposite angles. So we have got three conditions. So I can say that triangles are congruent by, look at the condition now. Here we have angle, angle and side. So this is AAS. This is AAS. Two angles and one side is not between the angles, side is separate. Angle, angle, side, AAS. We have to prove that CD bisects AB. So from here we can say OA equal to OB, CPCT. OA and OB are equal, CPCT, right? Because we have already proved the triangles congruent. And if OA equal to OB, we can say that CD bisects AB. CD bisects AB. With this, we prove that if OA and OB are equal, that means this line is dividing this into two parts, right? So OA equal to OB, so CD bisects AB. So that's question number 3. Now we move on to question number 4. Question number 4, L and M are parallel lines intersected by another set of parallel lines P and Q. Show that triangle ABC and CDA are congruent. Very simple question. They are parallel lines. So we know that if I take these two triangles, alternate angles are equal. So we are taking this triangle here. So I can say angle 1 equal to 2, alternate angles. Angle 3 equal to 4, alternate. And if you take both these triangles, you find that this line AC is common. Whether you take ABC or you take CDA, AC is common for both. So we have two angles and side in between. So angle, side, angle. Triangles are going to be congruent by ASA. So angle 1 is equal to 2 and 3 is equal to 4 by because they are alternate angles. And look at the two triangles. AC is part of both. So AC equal to AC common. And therefore, this question is very easily solved. They are congruent by ASA. 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 So triangles are congruent by ASA. 1 and 2, 3, 4. Two angles equal and one side in between. ASA. Question number 5. Line L is the bisector of angle A. So bisector means these two angles are equal. Angle 1 equal to 2. BP and BQ are perpendiculars. So this is 90-90 given. Prove that triangles are congruent. So if I want to prove the triangles congruent, APB and AQB, I have to see. So again, two conditions are already given. Angle 1 equal to 2 given. Why is it given? Because it is given that L is the bisector of angle A. Bisects means division into two equal parts. Then if you look at these two triangles, the angles are equal. Which angles? Angle Q and angle P are equal, right? So I can say that angle P and Q are equal. So I can number this 1 and 2 as per the triangles. So here I've got 1 and 2 equal and angle P and Q 90 degrees. So these two are already given. Now, what is the third condition? Look at triangle APB and AQB. You will find that AB is common for both. AB is part of both. So AB equal to AB common. So we have three conditions. So triangles will be congruent by which condition? Look at the figure carefully. This is angle and here also angle and AB is common. So that is a side, angle, angle, side. The side is not between the angles, side is separate, right? AB is here. These are the two angles. So AB equal to AB common. Triangles congruent AS, and therefore we can say BP equal to BQ by CPCT, corresponding parts of congruent triangles. BP and BQ are part of the triangles. If the triangles are congruent by CPCT, they will be equal. Now we go to question number 6. 6, 7, 8. The last three questions are important questions. Here AC is equal to AE given, AB equal to AD given, and angle BAD equal to CAE given. Okay. We have to prove that BC equal to DE. Now, what we need to do is, if I want BC, I have to take triangle ABC. Okay. BC is part of triangle ABC, and I want DE. So if I want DE, I will take this whole triangle ADE. So which are the triangles we are taking? Look carefully, ABC and ADE. Now already it is given that AC equal to AE. AC and AE are already equal. So AC equal to AD and AB equal to AD is also given. So two conditions are given to us. AB equal to AD, AC equal to AE. AB from this triangle ABC and ADE. AB and AD. AD is part of this triangle, right? So corresponding sides has to be taken. So AB equal to AE and AB equal to AD and AC equal to AE is already given. Now, many people take this as a condition BAD equal to EAC. But remember, we are taking this full angle. We are taking this full triangle BAC. And when you take BAD is only covering a small portion. BAD is not a condition for ABC. Because when you're taking ABC, there is a small portion still left. Okay. And when you're taking ADE, this angle, and then again, this has to be added to that. So what we are going to do, already it is given to you that 1 is equal to 2, right? BAD equal to EAC given. And then what we'll do, we'll add this small portion to both sides. So this is our condition 1. This is our condition 2. Now what we are going to do is angle 1 and 2 are equal given. Therefore, we can add that x to both sides. Euclid axiom we did that equal quantities, when you add to equal things, then that total will also be equal. So I'm adding x to both sides. So when I add x to both sides, what will I get? 1 plus x, that is angle BAC. Okay. And when I add 2 plus x, I will get angle DAE. So what am I getting? Angle BAC, this full angle equal to DAE, which can be used as a condition for the triangles that we have taken, that is ABC and DAE. So I've got three conditions now, two sides and one angle in between. So triangle BAD is congruent to triangle EAC by SAS. Triangles are going to be congruent by SAS. So this is the important step here. The two sides were already given, but what we need to do is add this x to both sides. We'll go on to question number 7, somewhat similar. Figure is different, of course. Question number 7 is this AB is a line segment. P is the midpoint of P is its midpoint. So AB is a line and P is a midpoint. That means AP and PB are already given equal. Such that angle BAD equal to ABE. So angle A and B are equal, and EPA, that means this angle 1, and angle DPB, that's angle 2, angle 1 and 2 are equal. Show that triangle DAP is congruent to EPB. So to prove this, look at the triangles very carefully. We are taking DAP, that is this triangle, and EBP, that is this triangle. Already we are given two conditions. Okay, the first condition I'm taking for this two, AP equal to PB is already given to me. So I'm taking this triangle APD, this triangle, and EPB. Already it is given that AP and PB are equal. Already it is given to me that angle A equal to angle B. So these two conditions are already given to us ready-made. Now for the third condition, again, if I take 1 and 2, they are not part of the triangles. If I look at APD, there is a small portion left here. So what I'm going to do is I'm going to add x, just like we did the previous. We can add x to both sides so that we get this full angle. So what we'll do, 1 and 2 are equal given. Therefore, we can add the x value to both. Okay. Just like we did the previous sum. And when we add 1 plus x, what are we going to get? We are going to get the full triangle APD. We will get the full angle APD, and here we will get angle BPE, which can be taken as a condition for the triangles, because we are taking triangle APD and triangle BPE. So APD is part of that. So APD equal to BPE, this will be our third condition. AP equal to BB first, angle A equal to angle B second. Once we have the three conditions, we can say triangles are congruent. So triangle DAP is congruent to triangle EBP. And which condition is this? See here, angle is there, side and angle. Side is between the two angles, so this will be ASA, and therefore AD equal to BE by CPCT. AD equal to BE by CPCT. So 6 and 7 are, you can relate it, more or less same. Okay, so we go to the next question, which is the 8th question. That is the last question of this exercise. And here, there are many parts, so we will do one by one. The first part, this is a triangle ABC, right angled at C. So this is 90 degrees. M is the midpoint of hypotenuse AB. So M is the midpoint, means AM equal to MB. DM and CM are already given equal. So this part and this part are also equal. Prove that triangle AMC is congruent to BMD. So first, I am taking triangle AMC and triangle BMD and proving them congruent. Look at the two triangles, AMC and BMD. Already see two conditions are given. And third condition is very evident. These are vertically opposite. So triangles will be congruent by SAS. So let me write it down for you. AM is equal to MB and CM equal to MD. Both are given in the question, because it is given that M is the midpoint of AB which means that AM equal to MB and DM equal to CM is given here. So two conditions were already there. AM equal to MB, CM equal to MD. And now we know that 1 and 2 are equal vertically opposite angles. And therefore what happens? The two sides, an angle in between, triangles are congruent by SAS. Triangles are congruent by SAS, right? Two sides and one angle. So first part is proved. Now we have to prove that angle DBC is 90. We know we want to, this is 90, we have to prove this is 90. So what we need to do for this is number these angles as 3 and 4. Okay, 1 and 2 was vertically opposite, number this 3 and 4. Now we have already proved that these two triangles are congruent. Which triangles? AMC and BMD. So the corresponding angles are going to be equal. That means A equal to B, or we can say 3 equal to 4 CPCT. Right? If the triangles are congruent, the corresponding angles are equal. It's starting from A here, it's starting from B here. So these are called the corresponding angles. So A and B are equal. So 3 and 4 are equal. So if 3 and 4 are equal, they are which type of angles? They are alternate angles. 3 and 4 are alternate angles. And if alternate angles are equal, what can we say? We can say that lines are parallel. So we can say that AC is parallel to BD. AC parallel to BD. These two lines are parallel. Now, if the lines are parallel, we know that co-interior angles add up to 180. So B plus C is 180, right? Sum of co-interior angles add up to 180. We know this. Once we know that they are parallel, they are co-interior angles, and C already is 90. So instead of C, I can write 90. So B plus 90 is 180. So what will angle B be? Angle B will be 180 minus 90. So angle B will be 90. If B is 90 means angle DBC is a right angle. Therefore, angle DBC is a right angle. I hope you got this. Once the triangles are proved congruent, we will say 3 and 4 are equal because 3 and 4 are part of the congruent triangles. So CPCT, but 3 and 4 are alternate angles. And if alternate angles are equal, lines are parallel. If lines are parallel, then co-interior angles add up to 180. So B plus C is 180. C is already 90. So angle B will be 90. So first and second part we have completed. Now we go to the third part. We have to prove that triangle DBC. DBC is congruent to ACB. That is the bigger triangles. Earlier we had proved these two small triangles. Now we are taking triangle DBC and triangle ACB. Now, since the small two triangles were congruent, I had already proved that AMC and BMD are congruent. So AC and BD are part of these triangles, right? AC and BD here are part of the triangles which we have already proved congruent. So AC is equal to BD or BD equal to AC. I can write BD equal to AC, CPCT of 1. I have already proved this. So corresponding parts of congruent triangles, which I have already proved. So we have BD equal to AC. That's the first condition, right? We are taking the triangles. Look at the triangles here, DBC and ACB. So BD equal to AC by CPCT of 1. And if you look at DBC and ACB, BC is equal to BC common. So that's our second condition. BC equal to BC common. Because whether you take DBC or ACB, BC is going to be common, right? And what will be our third condition? So we have already these two, and angle C was given 90 and we have proved angle B 90, right? Here we had proved that DBC is 90. So we get the third condition, B and C are 90. So you've got our three conditions, BD equal to AC, number 1, BC equal to BC common, angle B and C are 90 degrees. So you've got three conditions. So triangles are congruent. Triangles are congruent by, look at the two sides and one angle, right? So we have these two sides and this angle in between. So triangles are congruent by SAS. So this is the third part. Now we have to go to the fourth part, prove that CM is half of AB. Now once we prove this bigger triangle DBC and ACB congruent, then their corresponding sides are going to be equal by CPCT. So we can say that DC equal to AB. DC equal to AB, CPCT, right? DC and AB, the hypotenuse of the two triangles are equal. Now we can take half of both sides. Again, Euclid's axiom, if two quantities are equal, their halves will also be equal. So half DC equal to half AB. So here, instead of half DC, I can replace with CM. The reason being CM and MD are equal, right? So if I take half of this, half DC, so I am going to get, if I take half of DC, I'm going to get CM. So I can replace with CM is equal to half AB, which we had to prove, right? Half DC can be replaced with CM because CM and MD are equal. If CM and MD are equal, then we can say that half DC is equal to CM. And therefore, we get the fourth part, CM equal to half AB.